Okay, good afternoon. Naririnig po ako. Hello.
Yes po, ma'am.
Okay.
Yes po, ma'am.
Okay, so our topic for today is the design of pressure vessels. Okay? So ano po ba yung mga tinatawag natin as the pressure vessels? Okay? So these are simply containers having pressurized fluid. A fluid can either be a gas or a liquid. Okay? So ang pinaka-common po na example nito is the water tank. Okay? So yung water tank po, okay, commonly, they are in a form of a cylindrical containers. And then they have yung water inside. And sa labas naman po, you would observe na meron po siya na gauges. Okay? So the gauges, it points out to a number which corresponds to the pressure of the fluid inside. Okay? So yun po yung i-design natin ngayon dito. Okay? So for this one, okay, commonly the pressure vessels, okay, they are common as in a form of a cylinder, okay, but then there are those then na in a form of a sphere, and then there are others also, okay, like po yung in a form of a cube. Meron din naman po na rectangular parallelepiped. But then what is available on market is the cylindrical type and the spherical type. Yung others po, okay, yan ay common po na pinapa-fabricate na lang. Okay, if you insist on using those forms, okay? So, ang kalimitan po nakikita natin is the cylindrical and the spherical one, okay? So, ito po yung design po natin will focus on these two, the cylindrical and the spherical type. Yun po common na ginagamit po natin. Okay? So, if you are to choose po a pressure vessel, okay, so it is advisable po to use the cylindrical one. Okay? Although these two are available sa market, okay, it is more advisable to use the cylindrical. Why? Kasi ito po ay space saver. Okay? Space saver po ito kumpara doon sa sphere. Halimbawa po, you are to consider an increase in the volume. Okay? So, halimbawa po gusto natin mas madami yung volume na i-store po natin or ilalagay natin doon sa vessel po natin. Okay? So, we recall the equation for the volume for the cylinder. It is simply equal to pi r squared multiplied by the height. Whereas for the sphere, we have volume is equal to 4 over 3 pi r cubed. Okay? So, ano po yung ibig sabihin ko dyan? Why do we have there the volume? Okay? So, if we want an increase in the volume or expansion in the volume, okay, ano po ba yung way para natin itaas yung volume or yung capacity ng atin na vessel. Okay? So, para itaas po yung vessel natin, yung capacity ng sphere, we need to increase the radius or increase the diameter of the sphere. Okay? Yun po ay para makapag-hold siya ng mas madaming volume. Okay? So, need po natin na i-increase yung kanyang radius or yung diameter po niya. Okay? But then, doing that po, pag in-increase po natin yung kanyang diameter, that will entail po mas malaki din na space or mas malaking area kung saan mo ilalagay yung iyong vessel. Okay? So, you imagine kung gaano kalaki yung vessel mo having that diameter. Okay? So, it will consume a lot of space. Okay? Yung lot area dapat malaki talaga. Okay? Kaya, that makes it a disadvantage doon sa sphere. Hindi siya makapag-hold ng napakalaking amount kasi nga malaki yung space na gagamitin para sa kanya. Okay? Not unlike po unlike po doon sa cylinder, okay? Para po i-increase natin yung kanyang capacity, yung volume niya po, there are two ways. Una, yung increase po yung radius. Okay? Pero, hindi nga po advisable na mag-increase tayo ng radius kasi ang mangyayari, katulad lang siya ng sphere. Okay? Lalaki yung area na i-occupy niya. Okay? So, you should sort to the other one. Ano yun? I-increase natin yung height. Okay? So, the same radius siya, the same diameter siya, kaya lang patataasin natin yung cylinder. Okay? In that way, lalaki po yung volume and at the same time, same pa rin yung ma-occupy po niya na space kasi hindi mo naman binago yung radius na o yung diameter niya. Kumbaga, pataas lang siya. So, on the lot area to which it is mounted, yung ating cylinder, so, ganun pa rin. Okay, yun pa rin yung makukuha niya na area. Magagamit mo na area pa rin. Okay? Pero, napalaki mo yung kanyang capacity. It is because you change its height. Okay? Pinalaki mo, in-increase mo yung kanyang height. Okay? So, yun po yung advantage of using the cylindrical pressure vessel. Okay? So, hindi po siya nag-occupy ng napakalaking space. Kaya kung mapapansin niyo po, ang different industries, okay, kalimitan po, yung cylindrical vessel po, yan po yung ating ginagamit. Okay? Kung gumagamit man po sila nitong spherical vessel, ano lang po yan, for specialized fluid. Okay? Na kumbaga kung ilalagay mo siya doon, ay kaunti lamang na volume. Okay? O kaunti lamang capacity. Okay? Pero kapag po, alam mo, water tanks, so it is more advisable to use the cylinder para mas madami kang mailaman po sa kanya. Okay? So again, the design of the pressure vessels, dito po, ang gagamitin lang po natin or i-consider lang po natin is the cylindrical and the spherical type. Okay? So, how do we make po ba yung mga pressure vessels na yan? Okay? So, halimbawa po, it is cylindrical. Okay? So, kung cylindrical yan, okay? So, saan po ba siya nagmula? Okay? So, it comes from simply a sheet of metal. Okay? So, a sheet of metal, and then you have here po yung kanyang length, yung width, and then of course, yung kanyang thickness. Okay? Para po ba, alam mo, yero. Okay? Parang ganun. Manipis lang na ganun, tapos i-roll lang po natin. So, pag ni-roll mo, yung dalawa pong dulo, okay? Ito po yung isasarado natin. Okay? So you need to join the two ends, okay? Halimbawa, through welding or through rivet para magkaroon po tayo ng cylinder. Tapos yung dalawa pong dulo, tatakipan lang po natin the same material tapos i-weld din po natin yung mga duduhan. Okay? Para po walang maging leak po sa kanya. Okay? So again, it comes from this sheet of metal po. Okay? Now, there are two types po of this pressure vessel. We call them po the thin-walled vessel at ang isa naman po ay yung thick-walled. Okay? So, thin-walled po at saka thick-walled. Okay? So, thin-walled and thick-walled, common connotation po yan, sinasabi thin-walled when the thickness is thin. And when the thickness is thick, yun naman po yung thick-walled. But then that is not correct po. Okay? So, hindi po yun yung basihan kung paano sabihin na thin-walled. Halimbawa po, nakita mo dyan, thickness is 0.5 of an inch. Okay? Can you say that a thin walled or a thick walled? So, hindi po natin masasabi through the thickness only. Okay? So, meron po tayong tinatawag dito na limiting criteria. Okay? The limiting criteria is the ratio between the thickness and the inside diameter. Okay? The thickness over the inside diameter. Okay? This ratio should be less than or equal to 0.1 to be called a thin-walled vessel. Okay? It should be less than or equal to 0.1 to be called a thin wall. Okay, yan po ang maliwanag. Hindi po thickness lang yung basihan, kundi it should be the ratio. Okay, with the diameter. Okay, so if this exceeds this value, if it is higher than 0.1, then dito na po siya papatak, thick wall po. And when you design the pressure vessel, necessary po na ito muna po yung alamin natin. Okay? Alamin natin kung siya ba ay thin-walled and thick-walled. Okay? Kasi there are different procedures, okay, in designing a thin-walled vessel and that of a thick-walled Okay? May kanya-kanya pong paraan kung paano mo siya i-design. Kaya dapat po sa simula pa lang na i-design mo siya, dapat alam mo na kung siya ba ay thin-walled or thick-walled yung ating pressure vessel. Okay? At paano nga po yun aalamin? You use the limiting criteria. Okay? T over D sub I. It should be less than or equal to 0.1. Okay? Ano po ba yung pagkakaiba ng dalawa, ng thin-walled and thick-walled? Bakit kailangan pa nating alamin before natin na i-decide? Bukod sa magkaiba po yung kanyang procedure, ano po yung pinagkaiba ng dalawa? Halimbawa po, we take yung kanyang cross section. Halimbawa po ito yung ating cross section ng atin na vessel. Okay? So ito pong gitna, okay? This is where your pressurized fluid or your gas na andun. So ang pressure build up po talaga diyan nagmumula sa gitna. Okay? So let us now consider points on this cross section. Okay? So maglagay po tayo dito ng points. Alta ko lang po ito ng kulay. Okay, so maglagay po tayo ng points. Okay, halimbawa po, this one, okay, you call this your point 1. Ito po yung point 2, ari po yung point 3. Okay? So, ano po yung pinagkaiba ng tatlo? Okay? Point 1, point 2, point 3. Yung point 1 po is a point, okay, at the outside surface. Okay? So, yan po yung outside surface nun pong ating um, vessel. Okay? Yung point 2 naman po is along the thickness at yung point 3 naman po is the inside surface. Okay? So, pag ang tinanong po sa atin is, alin saan yung directly in contact with the pressurized fluid? Okay? So, it would be your point 3. At alin yung pinakamalayo doon sa fluid? Yun naman po yung 1. Okay? But then, yung 1 po is more affected by the fluid outside. Okay? So, yung fluid outside po, commonly, ay of course our air. Okay? Yung atmosphere po. Okay? Otherwise, may iba pa nakalagay siya doon sa ibang container. Okay? Kaya nag-iba yung value. But then kung hindi naman po, this ano lang po yan. Atmospheric lang po. Okay? So yan po yung atin na points. Okay? 1, 2, and 3. Okay? Yung 2 po again, it would be along the thickness. Okay? So, if you are to consider po the stresses, okay, so stress sa 1, stress doon sa 2, at saka doon sa 3, if this is a thin-walled vessel, okay, kung thin-walled po yan, yung stress po nung tatlo, okay, they are approximately equal. Kumaga, uniform yung value. Okay, we assume that to be uniform. So, meaning, each and every one is affected by the gas inside. Okay, since maliit lang naman yung thickness niya. Okay, yung wall niya. Okay, but then if it's thick walled po, yung stress at 1, stress at 2, and stress at 3, okay, malayo po yung pagkakaiba ng value. Okay? So, malayo-malayo yung value nila doon sa isa't isa. Okay? So, if you are to consider, alin ba yung pinakamataas yung value ng stress? Of course, the one which is in most contact doon sa pressurized fluid. So, pinakamataas po dyan yung nandun sa air. Okay? Yun po yung stress 3. Okay? Kaya sabi nga po natin, magkaiba siyang i-design. It is because magkaiba yung stresses na meron po siya if it's thin-walled and thick-walled. Okay? Kaya sabi nga po natin, when we design, okay, necessary first na unahin muna natin i-determine yung limiting criteria. Okay? Para malaman kung anong klase po ba siya. Okay, now let us take the case of a thin-walled vessel. Okay, so thin-walled muna po tayo. Paano ba i-design yung thin-walled vessel? So sa thin-walled, i-consider natin yung dalawa. Okay? Cylindrical at saka yung spherical. Okay? So unahin muna natin yung cylindrical. Yan, ito po. Thin-walled tapos cylindrical vessel. Okay? Alam mo po, ito yung cylinder natin. So, ang una po natin gagawin is to pass a cutting plane through it. So, ika-cut po natin this way. Say, we use cutting plane A prime. So, kinat po natin. Nung kinat po natin, ito na yung labas sa kanya. Ito na yung natira nung kinat po natin. So, ganito po yung itsura. Okay? So, you have here the exposed area now. Okay? So, from there, you compute now for the value of the stress. Okay? So, the stress is called the circumferential stress. Okay? So, the circumferential stress is simply equal to PD over 2T. Okay? This is derived from force over area. Stress is force over area. Okay? So, kung paano po ito dinerive, hindi ko na po uulitin. Kasi, I assume this has been derived to you on your mechanics of deformable body. Okay? So, from that equation po, you come up with the circumferential PD over 2T. Again, ang tawag po natin is a circumferential stress. And this is of course an induced stress. Okay? So induced stress po iyan kapag kinat mo po that way yung atin na uh, cylinder. Okay? So P of course pertains to the pressure inside the vessel. DI is inside diameter and T pertains to the thickness. So this is the stress on the material when you cut it this way. Okay? Another is, you have the cylinder and ganito mo naman siya i-cut along the length. Okay? So you use B prime, okay, as the cutting plane. So pag kinat mo po yan, ang mababawasan po sa kanya is the length. Okay? So you come up with this. Nandun po yung ating cutting plane, BB prime. So ito na lang yung natira on the left side. Okay? So ito po kayo yung kanya cross section. And you come up with another induced stress. We call it now your longitudinal stress. Okay? So symbol sigma sub L equal to PD over 40. Again, this is ano po, na-derive from sigma equal to force over the area. Okay? So, we come up with PD over 40. Okay? As our induced stress on the longitudinal section. Okay? So, dalawa po yung induced stresses natin. Okay? So, if you are to compare these two induced stresses, alin po ba yung mas malaki sa dalawa? Okay, alin po yung mas malaki yung value? Is it the circumferential or the longitudinal po?
Circumferential.
Okay, tama. It's the circumferential. So, bakit yung circumferential? Kasi kung siya po i-compare natin, okay, yung isa po, PD over 2T, PD over 40, dun lang po siya, ang pinagkaiba is the use of 2 and 4. So, ano po, you divide it only by 2. Ano naman, hinati mo pa sa 4. Kaya, sure po tayo na mas malaki po ito, circumferential stress. So, yung pong mas malaking stress, this is your critical stress. Okay? So, ito po yung critical stress natin. Okay? Kumbaga sa dalawa ay mas ano to, mas una itong makakasira over this. Okay? So, una siyang makakasira. Kaya, ito yung gagawin nating basis ng design. Okay? So, siya yung magiging basis natin ng design. Kaya, ano pong gagawin natin? So, for a good design, we equate. Okay? We equate the design stress to the induced stress of the material. Again, we make use only of the circumferential. Okay? Dahil siya yung bigger stress, siya yung critical stress. Okay? So, this is equal to PD over 2T. And your design stress, this can be sigma U over Fs or pwede din naman po na sigma Y over factor of safety equal to PD over 2T. Again, this would be used if basis is ultimate, this one if basis is the yield. Okay? So, ganun lang po kasimple. Okay? Para makuha po natin yung thickness. So, sa atin po sa design ng pressure vessel, ito po ang kalimitan na hinahanap. You're after the thickness of the plate. Okay? Yan po ang tinitingnan. Ano bang thickness ang aking gagamitin? Okay? Yan po yung critical. Okay? Kasi, dapat po yung thickness na gagamitin natin should handle the pressure inside the vessel. Otherwise, ay ano po yan, mag explode. Okay? Puputok po yung vessel natin sa sobrang taas ng pressure. Okay? So, dapat po yung thickness na gagamitin natin could handle that pressure po. Okay? Kaya yan po yung dinidesign sa vessel. Determine the thickness. Okay? And you can make use of this po. If that is cylindrical and then thin-walled, you simply equate the design stress to the induced stress of the material. And we will be using the circumferential PD over 2T. Now, let me go back dun sa illustration kanina. So, sabi ko nga po, it simply comes from a sheet of metal, okay? And then, kukunin natin yung thickness na yon, okay? Ang ginawa dyan, iniroll po natin, okay? Iniroll po natin to come up with your cylinder. Tapos, pinagdugtong natin dito sa edge po, okay? So, yung dalawang dulo, pinagdugtong po natin. So, meron po tayong tinatawag na efficiency ng pagkakadugtong na yun. So, ang tawag po natin doon is a joint efficiency. Okay? Yung JE po. Okay? So, if you are given a joint efficiency, okay, ito po yung sinasabi natin na joints. Okay? So, it can be welded or it can be riveted. Okay? Yung welded po, ibig sabihin, you have an electrode. Okay? Yung electrode po, atin po siyang i-melt. Tapos, yun pong melted na electrode, siya po yung ilalagay natin doon sa pinagtugtungan para po ma-join po natin yung dalawang ends. Okay? Ito naman pong rivet, ito po yung mga bilog-bilog. Okay? So, pag nakita po natin yung rivet, it is somewhat like a screw. Okay? So, katulad po ang itsura niya sa screw. Pero, hindi mo po siya pwedeng gamitan ng screwdriver para makalas. Okay? Hindi po siya nakakalas using the screwdriver kasi wala po yung thread. Okay? Yung po parang thread, yung ano man tawag doon sa Tagalog? Basta. Okay? So, yung thread po na yon, yung po yung iniikot. Okay? Parang naka-curl po doon na siyang iikutin para makalabas po siya or maalis mo po siya. So, ang ating pong rivet, wala pong thread. Pero, pag tiningnan mo po siya initially sa ibabaw, it is almost like that of a screw. Okay? So, yan po yung paraan kung paano natin nag-join yung mga ends. Okay? To come up po with your cylinder. Okay? Now, of course, this would affect po the performance of your pressure vessel. Okay? Kasi doon po sa parte na pinagtugtungan, okay, yan po ay nagiging stress raiser. Meaning, this becomes the weak point of your material. Okay? Nung iyo pong vessel. Na kung tumaas yung pressure, posible dyan siya bumuka, dyan siya pumutok. Okay? So, yun po yung ating need ngayon na i-counteract doon sa design. Okay? So, the weakness of this joint po should be cared of by the joint efficiency. So, kung kanina po, sabi natin sa design, we equate the design stress to the induced stress of the material. So, we say sigma D is equal to your circumferential. But, if JE is given, okay, kapag given po yung joint efficiency, ito pong design stress natin, instead of the usual design stress, ang gagamitin po natin, sigma D prime. Okay? Yan po yung equate natin to the circumferential. Okay? Why sigma D prime? Ang sigma D prime po, ang tawag po natin dyan, it is a lowered design stress. Okay? It's a lowered design stress to take care of the weaknesses doon po sa joint po natin. And this is simply equal to the design stress, the usual design stress, just multiply it po by the J. Equal to your ano po, yung circumferential stress. Okay? So, kumbaga, yung dati mo kanina, okay, na design stress po, okay, ito, sigma u over fs, ano lang pong gagawin? I-multiply lang po natin ito ng joint efficiency. Okay? So, ito po magiging ano, sigma u over fs multiplied by je equal to the circumferential or sigma y over fs multiplied by je equal to the circumference. differential stress. Okay? So, yan lang po yung nabago if the joint efficiency is given. Okay? At ang isang substitute po natin dyan, since this is efficiency, normally naka-percentage po yan, say 80%. So, ang ating pong isa-substitute dito should be the decimal equivalent, 0.8. Okay? Kung wala pong binigay, ibig sabihin 100% efficient. Kaya yun ay 1. So, you sort to simply the design stress. Sigma din lang po. Okay? Pero kung may JE po na value, ano po mangyayari? Lower design stress po ang tawag. Sigma D. Again, to be equated to your circumferential stress, kung siya po ay, ano po yan, thin-walled, and at the same time, it should be, ano po, cylindrical in form. O ha? Nasundan po ba? Hello? Hello?
Yes po,
Okay,
ma'am.
good. Let us have now number 2. Okay? So, ito naman po, thin-walled pa rin siya, but then this time, spherical naman po yung form niya. Okay? So, kung spherical naman po yan, okay? Halimbawa, we have this cutting plane A prime, o kaya papagan niya yung ating cutting plane BB prime. Okay? Kahit po pa crosswise o lengthwise po natin siyang hatiin, okay? Parehas lang po ang magiging itsura niya pag kinat mo natin ay yung kalahati. So, it boils down to an induced stress, okay, equal to PD over 40. So that is your longitudinal stress. Equal din po yan sa circumferential. Hindi po katulad kanina sa cylindrical, hinati mo ng papagani, hinati mo ng papaganito, magkaiba yung itsura. Pero ito, hatiin mo yan, papaganyan, paganyan, kahit saan, pare-parehas po yung lalabas. Kaya ang sabi po dyan, the longitudinal is the same as the circumferential. PD divided by 40. And this would be the basis of our design, okay? So, dyan po natin i-equate yung ating design stress, okay? So, the design stress should be equal to the longitudinal or the circumferential. And this is PD over 40. Ano po equal din na sa circumferential kasi sphere po yan, pare-parehas. PD over 40 equal to sigma D. Okay? Sigma D is sigma U over Fs or sigma Y divided by factor of safety equal to PD over 4. Okay? So, yan po yung gagamitin natin. But then, ganun din po ulit. Katulad po kanina, if joint efficiency is given, ano pong gagamitin natin? We use sigma D prime, the lower design stress equal to your sigma L. PD over 40. At ano po aring design stress natin? It is simply the design stress multiplied by JE, the lower design stress. Okay? So, parehas lang po. Okay? Ano lang pinagkaiba nyo dun sa kanina? Okay? Instead of PD over 40, 2T, PD over 40 po ang gagamitin natin kung siya po ay sphere. Okay? Pero ganun pa rin po yung design stress. Pag may JE, we are to multiply it to the design stress. Nakuha po ba? So, procedure po niyan, yan po ay para sa thin wall. Okay? Alin yung thin wall? Having a limiting criteria T over D sub I less than or equal to 0.1. Okay? So, yan po yung procedure para po i-design mo siya. Let us take the case now of a thin wall. Okay? So, alin naman po yung thick wall? So, alin ba yung thick wall? Again, if T over D sub I is greater than 0.1. Okay? Yan po yung thick-walled vessel natin. So, sabi nga natin, kapag thick-walled, hindi uniform yung kanyang stresses. Okay? So, yung nasa taas at yung nasa loob, okay, na surface at saka yung nasa labas na surface ng atin po na vessel, magkaiba yung value ng stresses. Okay? Nasaan yung mas mataas na value? Nandun po sa mas in contact with the pressurized fluid. Okay? So, kapag po thick wall yan, hindi na po natin pwedeng gamitin yung mga equations po kanina. Okay? But instead, ang gagamitin po natin is the Lames equation. Okay? Ano po yung Lames equation? Kung yan po ay thick walled, halimbawa po ito po yung ating thickness. Okay? So, sa Lames equation po, ang ginawa po diyan, ito pong thick-walled natin, dinivide nyo po sa madaming thin-walled. Okay? Ilan bang thin-walled yan? And then, yun po yung ay nano natin, hinanapan natin na equation. Okay? Yun po, doon po ginawa yung Leng's equation. Okay? So, these are the Leng's equation po. First, we have the hoop stress on the inner fiber. Okay, this is first one. Okay, hoop stress on the inner fiber. Okay, alin po yan? Kung ito po yung ating cross section, so ito po yun. Yan, yun po nandito. Okay, doon po sa point 3 kanina. Diga po kanina may points tayo. 1, tapos 2, tapos ari yung 3. So, ari po yung nandun sa 3. Okay, that is the hoop stress on the inner fiber. Okay, so we have the equation sigma T sub I equal to Pi quantity Ri squared plus Ro squared minus 2PO Ro squared over Ri squared minus Ro squared. Okay? Ano po yung Pi? Pi pertains to the pressure inside the vessel. Okay? So this is usually given po. Okay? It is the pressure of the fluid inside the vessel. Okay? Yung Ri naman po is the inside radius. So normally, the diameter is given, so you simply divide that by 2. Yung RO naman po, it's the outside radius. Okay? So, the outside radius is DO over 2. Okay? But then, do not expect that this RO be given. Hindi po yan ibibigay. Okay? Maalin lang po sa RI or RO yung magiging given, but not yung pong dalawa. Okay? Hindi po yan ibibigay. Kasi kung ibibigay po yan, okay, yung RO at saka RI, di ka po ay makikita nyo na or masosolve niya kaagad yung thickness. Tama? Okay? Kasi RO is equal to RI plus yung T. Therefore, yung thickness would be RO minus RI. Okay? So, kung ibibigay yung dalawang diameter na yon o dalawang radius na yon, okay, napakadali mo nang computein yung thickness. Nakuha po ba? Hindi ka na kailangan mag-Lens equation, hindi mo na yan kailangan. Okay? So, you expect na hindi ibibigay. Okay? Maalin dyan sa dalawa po na yan. Okay? So, ang gagawin mo po, you simply express one in terms of the other. Halimbawa po, yung RO. Yung RO po, papalitan mo po siya ng RI plus the thickness. Okay? So, meaning, it would be a function of the thickness. Okay? And then this one naman po, PO, this is equal to the outside pressure. Okay? So, outside pressure po yan. If this is not given, you assume to use po the standard atmospheric pressure. Okay? So, ang gagamitin po natin dyan is 1 atmosphere. Okay? Or equivalent to 14.7 psi. O kaya naman po ay 101.325 kilo Pascal. Okay? So, yan po yung ating atmospheric pressure. Again, if this PO is not given, assume to use this value po. Okay? Kasi alam naman po natin what surrounds us is the atmosphere. Okay? Kaya yan po yung ginagamit po natin. Okay? So, yan po yung mga parameters for solving the hoop stress on the inner fiber. We have the second equation for the links. We have the hoop stress on the outer fiber. Okay, alin naman po yun doon sa illustration natin kanina. Doon sa 1, 2, 3, ito po yung 1. Okay? Ito po yung nandun sa labas, outside surface. So, this is sigma T sub O. 2pi Ri squared minus PO quantity Ro squared plus Ri squared over Ro squared minus Ri squared. So, same parameter po doon kanina sa hoop stress. Then, letter C, we have the longitudinal stress. Pakipalitan nyo lang po, pakicorrect po. This should be sigma and then subscript L. Okay? Sigma, then subscript L. This is the longitudinal stress. Okay? That is Pi Ri squared over Ro minus Ri quantity then times T. Okay? So this is the longitudinal stress. Okay? So these are your limbs equation, the different stresses considering your limbs equation. And then above all, ano nga ba yung hinahanap natin? We are after the thickness of the plate. Di ba yan yung dinidesign natin? Ano ba yung thickness ang dapat gamitin? Okay? So ito po yung dalawang equation na gagamitin natin to know the thickness if it is thick wall. Okay? So you have your equation 1 and equation 2. Equation 1 will be used if material is brittle and equation 2 will be used if material is ductile. Okay, so for example, equation 2, material is ductile. So how do you know the thickness? Thickness is simply equal to di over 2 quantity sigma ti over sigma ti minus 2pi raised to 1 half. Okay, minus 1. Okay? So, you look at the equation, okay? So, yung iba, maiibigay, but then, given, but then this sigma ti, meaning, you need to solve it first, okay? Before you could solve for the thickness. So, necessary na i-solve mo muna po yung sigma ti bago po natin ma-solve yung thickness. So, babalikan mo po yung equation A po natin. Okay? The hoop stress on inner fiber, yan po yung sigma T sub I. So, you solve this first. Okay? Pag may value ka na po, doon mo po siya ngayon isa-substitute dito sa dalawang equation. Sa 1 o kaya po sa 2, depending upon the material of the vessel. Okay? But then, yung sigma Ti po natin, for sure, it will be a function of the thickness. Okay? So, may matitira po dyan. So, ang iyo pong simplified form nito is in terms of T. So, may variable po na T pa nakasama. So, yun na po mismo ang ating isa-substitute dito tapos i-simplify na lang po natin. Okay? Pag sinimplify mo po dyan, tsaka ka makakakuha ng value ng thickness. Okay? So, yun po yung gagamitin natin na thickness for a thick-walled vessel. Okay? Ang gagawin lang po is to convert this to the standard size or the commercially available size. Okay? So, ganyan po natin i-design kung siya po ay thick-walled vessel. Maliwanag po ba? Hello? So, you have there the two procedures po na ina-apply po natin. Okay? Kapag po thin-walled at kapag po thick-walled. But then, saan po again lahat magmumula? Dito po sa limiting criteria. Ari po yung uunahin natin. Okay? But then, take a look at the limiting criteria po. Tingnan nyo po ulit yung limiting criteria. Okay? Ang limiting criteria is dependent on, okay, T over D sub I. Okay, di ba? Yun ang una, okay? Limiting criteria is T over D sub I. And you look at this value, okay? This is unknown po. Okay? Yan po yung unknown. So, paano po ako makaka-proceed with my design procedure? Eh, dini pa lang po sa limiting criteria, nandun na yung unknown. Okay? So, para pong ito yung yung dun sa atin na compression, wherein you have the slenderness ratio, tapos case 1 up to case 3. So, ganun din po halos dito. Okay? Meron kang limiting criteria, pero it's an unknown din. Okay? Kaya, hindi mo din ma-proceed. Kaya, anong gagawin mo? You start again with an assumption. Okay? So, ganun din po ang gagawin dito. Ayun lang dito, you assume first it is a thin wall. Okay? You assume thin wall po. Okay? Tapos, you can proceed with the procedure for thin wall. You can have your value. Okay? Tapos, ito pong nakuha mo, hindi mo sure kung tama. Kasi nga, assumption yung start mo. So, anong gagawin? You need to verify. You need to check. How would you check? You go back to the limiting criteria. Dini mo, isa-substitute yung thickness na nakuha mo, and if ever this is less than or equal to 0.1, then you say, it is really thin-walled. So, tama po itong answer natin. Okay? Pero pag chinek mo po siya, sinubstitute mo po siya dun, and it is greater than 0.1, then therefore it is thick-walled, so you need to recompute. Okay? So, you need to recompute using ano po, yung Lenz's equation. Nakuha po ba? Naintindihan po ba yung sinabi ko? Hello? Okay, so halos parehas po nung sa compression. Mas madali lang to kasi ano siya, dalawa lang cases. It's either thin wall or thick wall. Okay? Okay, let us have this sample problem. Okay, so we have here samples 1 and 2. Okay, unahin muna natin yung 2. Yan. You determine the safe wall thickness of a 30-inch steel tank with internal pressure of 7.82 megapascal. Yield stress of the material is 275.48 megapascal, and a factor of safety to use is equal to 2. Okay? So notice that on the sample problem 2, okay, ang ginagamit po natin, okay, mostly are in the SI unit. Okay, these are on megapascal. So, naka-SI po yan. So, ito po yung tatandaan natin. Pag ang given problem po sa atin, okay, uh, given are all in SI, so ibig sabihin, isosolve po natin siya using the SI unit. Okay, so ang final answer po natin should be in SI also. And how it is solved, dapat po naka-SI din. Okay? Kaya ano pong gagawin natin? Yun pong nasa design table, halimbawa po, mga ilangan po tayo ng value ng sigma U, okay? O kaya po ay sigma Y, okay? Yan, sigma U and sigma Y, di po ba yan makikita natin sa design table. And then this, usually, they are expressed in KSI sa table po natin. So, ang gagawin po natin, ito po yung i-convert natin to megapascal or kilopascal po. Okay? So, ganun ang gagawin natin. On dun po sa parte ng material specification, isusulat mo doon, sigma U equal to, say, 50 KSI. Sigma Y equal to 40 KSI. Doon mo na po siya i-convert into megapascal. Okay? Yun ay kung makita mo po na yung ating mga given is in the SI. Okay? Doon mo po siya papalitan. Ano po yung magiging conversion dyan? Ang conversion po dyan ay katulad lang sa pressure. Okay? Ang conversion would be 14.7 PSI. This is equivalent to 101.325 kilopascal. Okay? So, yan din po ang gagamitin natin conversion dito on your sigma U and sigma Y values. Okay? Yan. So, let us take the case po of the sample 2. Isosolve po natin ito using yung SI unit. Okay? So, let us state first the given values. Okay? So, given first is the diameter. Okay? This time, yung diameter naman niya naka-English unit. Okay? So, the diameter is equal to 30 inches. So, you convert this po into mm. Okay? So, paki-convert na lang po. And then after that, you have your internal pressure. So P is 7.82 megapascal. Okay? And then after the given, we have po our material specification. Now, wala po ditong binigay na code, okay? Ano lang po nakalagay? It is simply a steel, but then the property is already given. Yield stress is given equal to 275.48 megapascal, okay? And nothing else, okay? Meaning, given yung sigma y, therefore, it is an implication that the design would be based on the yield strength, okay? Next would be the factor of safety. Okay, so for the factor of safety, it is equal to 2 since this is given. Okay, so yun po ang Fs natin. And the next to it would be the design stress. Okay, for the design stress, we use sigma D equal to sigma y over factor of safety. Again, it is based on the yield since ang given po sa atin is sigma y lamang. Wala pong binigay na sigma u. Okay? So, sigma y, we have already the value. That's 275.48 megapascal. Then, divide that by the given factor of safety equal to 2. then you'll have your design stress in megapascal. Okay? So, mamaya po, I'll give you time para po i-complete po itong solution natin. Okay? So, you solve it on your own po. Okay? Binibigay ko lang po sa inyo yung flow ng solution. Okay? So, after po ng design stress, that is for you to decide whether, okay, this vessel is a thin-walled or a thick-walled. So, you go to the limiting criteria. Okay? Limiting criteria. T over D sub I. But then, sabi nga natin, this T is unknown. Okay? Yung T po na yan, yan po yung unknown. Okay? Kaya, hindi po tayo makakukuha ng limiting criteria. Hindi po natin malalaman whether it's thin-walled or thick-walled. So, ano pong gagawin natin? We simply assume. Okay? So, assume thin-walled. So, pag na-assume po natin na thin-walled, we go to yung procedure of designing a thin-walled vessel. Okay? So, ano pong gagawin? You equate. For a good design, okay, equate design stress to the induced stress. And the induced stress is your circumferential stress equal to PD over 2T. Okay? PD over 2T. Your sigma D, na-solve po natin dito. Okay? Yung P po is 7.82. Yung DI is 30 inches to be converted in millimeter. Therefore, you can solve for the thickness. Okay? So, isolve po natin yung thickness. And then, tingnan po natin mamaya kung ano yung mangyayari. Okay? So, after po ma-solve yung thickness, you are not sure if this is correct. Kasi, we started with an assumption. So, you need to prove this assumption. Kaya na po after nito, you go back to the limiting criteria. Okay? So, sa limiting criteria ka po babalik. Okay? T over D sub I. Yung sagot mo po dito, yun pong ipapalit dito. Okay? And then, tingnan mo. Is it less than or equal to 0.1? Pag yun po yung nangyari, it is really thin wall, then this thickness should prevail. Okay? This thickness would be your final answer. But then if not, it is greater than 0.1, you need to recompute using the uh, Lane's equation. Okay, so I'll give you now time to provide po yung answers po dito. Okay, tingnan po natin, is this really the final thickness po? Okay, so sige po, pakisagutan muna po before I continue. Paki-compute muna po. Okay, ano yung sagot natin? Okay, you can use the chat box for the answers. Okay, so first we have here the 30 inches converted to millimeter. What is the value? Hello? Okay, 762 mm. Okay, so 762 mm. Now, we have this sigma d. Okay, we go to the design stress. So for the design stress, we say it's sigma y over the factor of safety. So you simply divide 275.48 divided by 2. And this will give us what value? 100. Okay, correct. 137.74 megapascal. And then from this, okay, you use this design stress, okay, to determine the thickness. Okay? So, sa thickness naman, malalaman po natin yon, okay, using, okay, yung kung pressure natin, 7.82 megapascal, DI is 762 mm, divided by, okay, yung 137.74 megapascal times yung 2. Okay? Then you'll determine po yung thickness. What is the value this? 21.631. Okay? So 21.631 mm. Okay? So this is our answer. Okay? But then again, we are not sure of this value. Okay? So we need to check using the limiting criteria. So using that value, 21.631. Okay? You use the real value po ha, divided by 762 mm. So you cancel out millimeter and T over D sub I. Value is the limiting criteria 0. Okay, 028. Okay, 0.028. And you look at the value now. Okay, this value T. Okay, so since T over D sub I, you are sure that this is less than 0.28. Okay? 0. Sorry, 0.28. Okay? This is less than 0.028. Okay? So, wala na po akong makikita dyan na less than or equal to. Hindi po, okay? So, sorry. This is a less than 0.1. Okay? So, this is less than 0.1. Okay? So, dapat po wala ng equal kasi hindi naman siya talaga equal. You have the value already. So, the value is less than 0.1, then it is really thin wall. Okay? It is really thin wall. Therefore, you can have your conclusion now. Therefore, use T equal to 21.631 mm, and then you convert it to the standard size, 22 mm. Okay? So, the standard size sa SI po, if it is in mm, okay, it should be the next full number. Okay? It should be the next full number. Say, 21.631, that is 22 mm. Hindi po ito katulad nung ginagamit natin sa English unit na may fraction, yung 1/8, 1/4, okay? Hindi po. Kasi yung mm, sobrang maliliit na po yun. Kaya it should be the next whole number na po. Okay? O even halimbawa po, ang nakuha natin ay 21.325 for example, mm. Okay? This is the same po na din na 22 mm na din po yan. Next whole number na po. Okay? Kahit po pag kung i-round off mo po siya sa 21, hindi po. It should be the next whole number. Okay? So, ganyan po natin siya gagawin. Ito po yung sinasabi ko. Kung dito po sa parte na to, ang nakuha natin is greater than 1, di ilalagay po natin greater than 0.1, then thick walled, recompute using the Lames formula. Tapos, tsaka ka po ma-re-recompute. Okay? So, ganun po yung ginagawa. Let us have po the sample problem 1. This time po, you determine the bursting steam pressure of a steel shell with diameter of 10 inches and made of 1/4 thick steel plate. Joint efficiency is at 70% and the tensile strength is 60 KSI. Okay, so we identify. Okay, ito po would be the diameter. This one po would be the thickness, efficiency, this is JE, and then this one, tensile strength, would be your sigma U. Okay? So, ilista po natin. Okay? So, what are the given? Inside diameter is equal to 10 inches. Okay? And then we have there the thickness, 1/4 inch, or we say this is equivalent to 0.25 of an inch. And then we have joint efficiency, that is 70%. Okay? And then material specs. So just like po yung kanina, it is simply stated as steel. But then your sigma U value this time is given. So with the given sigma U, it is an implication that the design would be based on the ultimate strength. Okay? And then next would be the factor of safety. Now, this is a different case po. Okay, bakit po ito different case? Dito po kasi sa problem, ang hinahanap po is bursting steam pressure. Okay, bursting steam pressure. So, yung pong pressure kung saan posible na po sumabog yung atin na vessel. Okay? So, with that po, hindi po natin siya pwedeng lagyan ng factor of safety. Kasi, pag in-incorporate po natin ang factor of safety, yung pressure po na makukuha natin will be a safe pressure. Okay? It is a safe pressure. Kaya, ang hinahanap po natin ay yung kung kailan po magkakaroon ng bursting. Okay? Kaya, hindi mo po dapat lalagyan. Okay? So, it's special po ito dito sa case po na ito. Okay? Kaya, for the factor of safety, just leave it blank. Okay? I-ignore muna po natin ngayon yung factor of safety because we are after this bursting steam pressure. Okay? Now, after the factor of safety, we have the design stress. Okay, so for the design stress, we have there sigma D is equal to your critical stress or the longitudinal stress. Okay, so ito po from the word here, steel shell. It's an implication that it is a spherical vessel. Okay, so spherical vessel po yan. Kaya ang gagamitin po natin dito is PD over your 40. Okay, PD over 40. Now, so design stress is equal to your critical stress. At ano po yung ginagamit natin? For the design stress, it is simply equal to sigma U, okay, divided by the factor of safety. But then sabi nga natin ay, hindi natin kailangan dito yung factor of safety because we are looking for the bursting steam pressure. So we therefore say that design stress is equal to your sigma U. But then, meron po tayong joint efficiency na given. Okay? So, if JE is given, ano po ang ginagamit natin? Instead of using sigma D, ang gagamitin po natin would be sigma D prime equal to your sigma U. And what is sigma D prime? Ano po ba yung sigma D prime natin? Your sigma D prime, okay, is simply equal to your sigma D multiplied by JE equal to your sigma U. Okay? Nakuha po ba? Hello?
Yes po,
Okay,
ma'am.
so yan po ngayon yung magiging value. Okay? For your design stress. And then, ang kasunod po niyan is to determine whether it is yun pong thin walled or thick walled. Okay? Kasi doon makikita natin kung anong procedure ang gagamitin. So, we solve for the limiting criteria. Okay? T over D sub I. Okay? So, you are given now the thickness, 0.25 of an inch. And then DI is 10 inches. So, you cancel out inches, you'll have 0.025. So, given this value, ano po ito? Thin walled or thick walled?
Tinwal po, ma'am.
Okay, correct. So, therefore, thin walled. Okay, so since T over D sub I, okay, is less than 0.1, then thin walled. Okay, so kung thin walled po yan, we follow procedure for thin walled. For a good design, okay, your design stress, sigma D, okay, equal to your longitudinal. Okay? Ang gagamitin natin is the lower design stress. Okay? So this is equal to PD over 4T. Okay? PDI 4T equal to your sigma D prime. And what is your sigma D prime? It is equal to 1. Okay? Sigma D times JE equal to your sigma U. Okay? So yun po yung ipapalit natin dito. Okay? And then you can compute for the pressure. Okay? Kindly compute nga po. Sige po, i-substitute niyo po yung value, then what is the value for the pressure? Yun pong iba. So, for Almac, that is 4.2 KSI. The others, tama po yung sagot niya. This is 4.2 KSI. The others nga po, they yield the same, okay? Yan. Yan, madami na nakukuha. Okay? 4.21, 4.2. Okay. So, this is the answer po, 4.2 KSI. Okay? So, ano po yung ibig sabihin nito? Again, this is your bursting stream pressure. Okay? Meaning, hindi po tayo naglagay ng factor of safety. Okay? Kasi, kung nilagyan po natin, sinamahan niya natin ng factor of safety, hindi po ito yung pressure na makukuha natin. Okay? Ang makukuha natin po would be a safe value of the pressure kasi we incorporate a factor of safety. Okay? Kaya hindi wala po siyang kasama. So, we use simply this. Okay? So, ibig sabihin, pag ginamit po natin ito, okay, failure would most likely to occur. Okay? Mag-explode po yung atin na pressure vessel. Okay? So, may question po ba sila? Hello?
Wala naman po, ma'am.
Wala na. Okay. So, sige po. I hope lang po na nakuha po natin yung concept of designing a pressure vessel. Okay? Whether it's thin-walled o kaya po ay thick-walled. Okay? I'll stop my presentation now. And then you open your camera po for a quick attendance check. Everyone, Olma, you take charge. Okay na po? Okay. Okay, thank you, thank you. Okay, so you
Sige
continue
po.
working na lang po on your design work. Okay, sige po, bye.
Salamat.
Sige po,
Sige po,
ma'am.
ma'am. Sige po.